Hi everyone, so we're going to talk about the atomic radius and its trends on the periodic table. We'll need our notes as well as table S. So we'll talk about what atomic radius is and factors that contribute to it, which are nuclear pull and shielding, some trends across a period and down a group, and we'll talk about table S as well. So when we have the atomic radius, it's, let's think about the radius of a circle. The radius of the circle is the distance between the center and the outermost edge of the circle. If we think about what an atom is, well, an atom is the smallest unit of matter. It consists of protons, neutrons, and electrons. So if we think about the atom, inside of a nucleus would be protons and neutrons, and we'll talk about these more in depth later on. And outside of that nucleus are energy levels. And inside of those energy levels will be electrons. So we have electrons here and there, and we'll show later on a little bit more detail on how to draw these. But basically, we want to show that the radius itself is going to be the distance from this nucleus to the outermost edge. So right here is going to be our radius. Now, the outer edge of electrons, whatever it might be within the first energy level, the second energy level, whatever, they're called valence electrons. So make sure you have that as a definition or a term in there. You can always find atomic radii on table S. They're listed there for you. And just to give you a little bit more kind of visual here, let's take a look down group 1. Now, the periods tell you how many energy levels that atom will have. So hydrogen is in period 1, which is row 1. It has 1 energy level. Lithium is in row 2 or period 2. It has 2 energy levels. Sodium has 3, and potassium has 4. So as you go down, you can see that the distance between the nucleus and the outermost edge gets to be a little bit bigger. And it's kind of hard to show that as a clear line here. But you can see that it gets larger. So as you go down the radius, or excuse me, as you go down a group, that radius gets larger. So there's a few factors that contribute to atomic radius, or at least pretty much what's happening inside the radius. One we have is nuclear pull. So the nucleus, of course, is made up of protons, which are positive, and the energy levels are made of electrons, which are negative. So here we have an electron here. It has some attraction to these protons. Shielding is when we have repulsion. So if we have an electron here and an electron there, they're going to repel one another because they're going to be the same charges. So if we talk about what's happening within the groups, we know that down the group we have more energy levels, therefore we have a larger atomic radius. But if we go across the periods, for example, period 2, which has 2 energy levels in each one of their atoms, so it looks like they have the same number of energy levels, so the atomic radius should be the same. But since there's more electrons, there's actually more attraction. There's more nuclear pull from the radius of the atom, or the nucleus of the atom, to the valence electrons. So as we go across, the radius actually decreases because there's more nuclear pull. As we go down, there's a greater radius because, again, there's more energy levels, but also because there's more shielding. So these negative electrons, let's take a look at potassium, are all repelling one another, meaning they want to get as far away from one another as possible. So because of that, the radius itself is getting larger. Okay, sorry about that. So here's another thing showing you at least the main group elements. The last picture is showing you the main group elements as well. So of course, as you go across, the radius decreases. As you go down, the radius increases. So make sure these arrows get down on your reference tables as well. And this is showing you all of the elements here. So again, as you go across in the main group, the atomic radius decreases because there is more nuclear pull. As you go down, the atomic radius increases because there's more energy levels and more shielding. But inside of the transition elements, the radius can definitely vary. So if they ever ask about any of the radii in here, make sure you take a look at what table S has listed for you. So to summarize, atomic radius is the distance between the nucleus and the outermost electrons, called the valence electrons. Across a period, the radius will decrease because there's more nuclear pull, and down the group, the radius will increase because there's greater shielding and also more energy levels. Have a great day, guys.